Section 3.2 is solving inequalities using addition or subtraction. I can use addition or subtraction to solve inequalities. Big ideas here. In the same way equations are solved using properties of equality, inequalities are solved using properties of inequality. The addition and subtraction properties of inequality can be used to solve inequalities. So, equivalent inequalities are inequalities that have the same solutions. A couple take notes here. On page 171, the addition property of inequality says that we can add the same number to both sides of an inequality and keep it an equivalent inequality. The subtraction property of inequality on page 173 says we can subtract the same number to both sides of an inequality and keep an equivalent inequality. So in example 1, we are going to get the solutions of our inequality and then graph them. So right now, my x is being subtracted. We get rid of subtraction by adding. And whatever I do to one side of my inequality, I have to do to both, just like with equations. So here, I have x, negative 15 plus 15 is 0. My inequality didn't change. Negative 12 plus 15 is 3. So x is greater than 3 is my solution. To check that, we plug it back in. This is our boundary point. So we should get a true statement if we plug it equal. Negative 12 equals negative 12. So we have the right boundary point. Remember, our boundary point splits our graph from everything that is true and makes a solution to everything that is not. Now on our graph, we put our boundary point in the middle, one number bigger, one number smaller, and 0. Circle at our boundary point. We look here, it's not equal to, so we don't fill it in, but we want numbers that are greater than 3, like 4 and 5, and everything on this side. Now we can check that. Let's plug in 4. 4 minus 15 should give us a number greater than negative 12. Negative 11 is greater than negative 12, so that checks. Example 2. Here, my x is being subtracted by 3. We get rid of subtraction by adding. And whatever I do to one side of an inequality, I have to do to both, just like I did with equations. Here I get 13. I keep that inequality is greater than or equal to x, because negative 3 plus 3 is 0, and x plus 0 is x. Now, we can check that our boundary point is right by plugging it in. 10 should be equal to 13 minus 3. Again, that boundary point should be equal. That tells us where our equation is equal because everything on one side is greater, everything on one side is less. 10 equals 10 here, so our boundary point is right. Now, let's graph it. We put our boundary point in the middle, the next consecutive number higher and lower, and make sure we have 0 somewhere. Circle at our boundary point. If we look here, it's equal to, so I'm going to fill it in. We want 13 to be greater than our numbers. 13 is greater than 12 and 0, so we shade everything on this side. To check to see if that's right, we take a number in our solution, like 0 for example, and plug it in. 10 is greater than or equal to negative 3. That's true, so my graph is correct. This is good, and so is that. Now feel free to pause here and give this a try. We want to know the solutions and graphs of our inequalities. N is being subtracted by 5. We get rid of subtraction by adding, and whatever I do to one side of my inequality, I have to do to both to keep it equivalent. Here, negative 5 plus 5 is 0, so I have n. Keep my inequality, negative 3 plus 5 is 2. I checked that boundary point, so we are correct with that. Now, we're going to graph it. We put our boundary point in the middle, the next number bigger, next number smaller, make sure we have 0. Circle at our boundary point. If we look, it's not equal to, so I don't fill it in here. We want numbers that are less than 2, like 1 and 0. So we shade there. Here I checked one number in my shading part, which is my solution set. It was right, which means everything on that side is right, so our graph is right. Feel free to give B a try here if you'd like. My variable is being subtracted by 11. I get rid of subtraction by addition. Whatever I do to one side of my inequality, I have to do to both to keep it equivalent. Negative 11 plus 11 is 0, so I just get m. Bring down my inequality, and negative 2 plus 11 is 9. I set both sides equal with that boundary point and got a true statement, so my boundary point of 9 is correct. Now we can graph. Again, we put our boundary point at 9 in the middle. Next number bigger and next number smaller. Make sure you have 0 on there as well. 0 is a good test point to help us know which way to shade. We put a circle at our boundary point. We want numbers that are greater than 9, like 10 and 11, and really big numbers with our arrow. So we shade everything on the side of our solution. So that's the purpose of these numbers on each side, next number bigger, next number smaller, is because sometimes those are really helpful to help us figure out which numbers are bigger, which numbers are smaller, and which way to shade. Here I plugged a number like 10 from our solution set into the equation. I got a true statement, so our graph is correct. In 3, t is being added by 6. I get rid of addition by subtracting. Whatever I do to one side, I still do to both, just like with equations. 6 minus 6 is 0, so I just have t. Bring down our inequality. Negative 4 minus 6 is negative 10. I checked that boundary point by setting both sides equal, and it is correct. So now we can graph. Put my boundary point in the middle, next number bigger, next number smaller, and 0. Put a circle at our boundary point. Here, it's not equal to, so we don't fill it in. We want numbers that are greater than negative 10, like 0. So, and negative 9. We shade everything on the same side as our solutions. Remember, our graph was split. Everything on one side is true, everything on the other side is not. So if one of our answers is true, then everything on that side is, if one of our numbers is. Example 4. The hard drive on your computer has a capacity of 120 gigabytes. You've used 85 gigabytes. You want to save some home videos to your hard drive. What are the possible sizes of the home video collection you can save? So here, the amount that we use can be less than or equal to the amount that we have. Okay, we don't have to use all of our storage, but we can. We can't use any more than that. So here, the amount that we have is 120 gigabytes. The amount that we use is 85, plus we want to save some videos. My variable is being added by 85. It's a positive 85 here. I get rid of that by subtracting. Whatever I do to one side, I have to do to both. 85 minus 85 is 0, so all I have left is v is less than or equal to 35, and my label here is gigabytes. Now feel free to pause here and give this a try. Our variable is being added by 12. To get rid of addition, I subtract. Use that subtraction property of inequality, which is very similar to our subtraction property of equality. It says as long as we do it to both sides, it stays equivalent. 12 minus 12 is 0, so all I have here is y. I bring down my inequality. Negative 1 minus 12 is negative 13. I keep my y on my right side, my negative 13 on my left. Now, if we check our boundary point there, we get a true statement. We can graph it by putting our boundary point in the middle. One number bigger, next number smaller, and where 0 goes. We put a circle at our boundary point. Here, because it's equal to, I fill it in. We want 13 to be greater than our numbers. 13 is greater than negative 14, negative 20, things like that. So we shade everything to the left, everything lower. Here, I plugged in a value like negative 14 to check. It gives us a true statement, so our shading is accurate. Now, a club has a goal to sell at least 25 plants for a fundraiser. Club members sell 8 plants on Wednesday and 9 plants on Thursday. What are the possible number of plants the club can sell on Friday to meet their goal? So, the club sold on Wednesday and Thursday and Friday, and they want to sell at least, which means they could sell equal, they could sell more, but they can't sell any less than 25 plants. Here we know on Wednesday they sold 8 plants. They sold 9 plants on Thursday. And we are looking for Friday. We can combine like terms. 9 plus 8 gives me 17 plus f is greater than or equal to 25. So to figure out for Friday, f is being added by 17. We subtract 17 to both sides. And again, as long as we do it to both sides of our inequality, it gives us an equivalent statement. So on Friday, they have to sell at least 8, which means equal to 8 or more than 8. Quick recap here. In the same way equations are solved using properties of equality, inequalities are solved using properties of inequality. And the addition and subtraction properties of inequality can be used to solve inequalities. So if we add the same number to both sides or subtract the same number to both sides, it's still equivalent, just like it was with equations. And that's all I have for section 3.2.